So hello guys, welcome back. This is Surendra. So in last video we have done 3 variable K-map. In this video we are going to start the 4 variable K-map. There is nothing more difference in 3 variable and 4 variable. Just we have increased 1 variable. So the all rules which we have followed in 3 variable K-map we will going to follow in 4 variable K-map also. So firstly let us start with 4 variable K-map. Suppose I have 4 variables A, B, C, D. A, B, C, D, and here we mark the number as reflected code, and I have given the clue that why we are marking the reflected code. And then we are going to this is MSB and this is LSB, so we are going to mark this one like this 00 and this 00. The decimal equivalent will be 0, so here will be minterm 0, and like that I have already described in 3 variable K-map. So I am directly writing like M1, and here will be M3, here will be M2, here will be M4, here will be M5, here will be M6, M7, this will be M8, this will be M9, this will be M11, this will be M10, this is M12, this is M13, this is M15, this is M14. So this is the value of minterms, and nothing difference. Just we have to make same pair and like that. So I will give you an example of gate 17 and electrical. So I will give the example, only one example, then we will move forward. So guys, this is electrical 17 gate for 1 marks question. So they have given this K-map, and we have to minimize the K-map and then calculate the expression, Boolean expression. So how we will calculate? I have already said that we have to go through the maximum possible pairing. Like firstly we will check that is there any possibility to make octant, then quad, then pair, otherwise minterm. So firstly I have said that we can fold this K-map also. So if we will fold this, so this one will make a pair, quad, sorry, this will make a quad, and we can make this one as pair. So how we will write the equation? I have said that that one is not changing, we will consider that one. So here B into here which is not changing, 0, 0. So 0 means D bar, BD bar plus for this one AB into C, AB into C. So this will be the answer for this problem. And then I have to say some concept, like if in K-map if we have diagonal adjacency, means we have only one diagonal element, then we can't minimize further. Like suppose take it as 3 variable K-map. So this is 3 variable K-map, and we have element like this one only. So they are diagonal, they element are in only one diagonal. So this is called diagonal adjacency. So when diagonal adjacency occur, then we can't minimize the further, and the result of this one will be result of the Boolean expression of this K map will be XOR or XNOR or combination of XOR and XNOR. These three cases are possible when diagonal adjacency occurs. So means when we have the element only on diagonal, so that is called diagonal adjacency. And so till now we have done the problem, all the problems for K map. I will try to bring some new problems for K map, and I have to introduce some more terms, so please wait for 2 seconds. So guys, I am going to introduce the implicant, prime implicant and essential prime implicant. This is also the part of K map. So this is some concept, means we have to keep in mind that this is called implement, this is called prime implicant, this is called essential prime implicant. So firstly, implicant. So implicant is nothing but min-terms. Whatever min-terms we have, like suppose this one we have this one came 1 1. So this is called implement, means both. So this is called implement. Then prime implicant. It is the form of combining maximum possible adjacent cell. So I will give you the example for prime implicant. So like this is the example for so how much pair this is A, B, C, this is same, you can make number. So how much pair you can make in this one? So in this one we can make this pair. So you have to make maximum possible the pair of adjacent cell. So we have make 1 2 3 4 5, and here one more 6. So here the prime implicant for this K map is 6. And what is the how much implicant we have? We have 1 2 3 4 5 6. So implicant we have 6. So we have another new terms, and then I will combinedly I will describe by I will give 2 methods how to calculate that one. So guys, essential prime implicant. It is the prime implicant which contain one min-terms which is not covered by any other prime implicant. So it is the implicant which is not covered by any other prime implicant. So I will give the example, then we will describe that how we will calculate the essential prime implicant. So we will see. So I have taken this example, and I have already said that how to calculate prime implicant and implicant. So implicant is just number of min-terms. So in this the number of min-terms is 5. So implicant is 5. And then prime implicant. How to calculate prime implicant? We have to make a maximum grouping. So here one group, and here one group, and here one group, and one more here. So the prime implicant is 1 2 3 4. So for this equation the prime implicant will be 4. and the essential prime implicant, as I have said that the implicant which is covered only once, so these two have covered only once. So in this for this K-map we have two essential prime implicant. And we have another method for this one, like we will write the Boolean expression separately, and then we will see which part is common, that will call essential prime implicant, and how much term we have, that will called for prime implicant. So I will do this problem once. So in both the example we have to make the pair differently. So like in this one I am making the pair like this one and this one and this one. For this one we can make like this. So write the equation for both the here 0 0 0 1 1 1 1 0 0 1. So for this pair we have a bar and c bar, a bar c bar, plus for this we have b bar c, plus for this one we have b c bar. For this equation so for this we have a bar and b bar. For this b bar c, and for this b c bar. So like I have said that which term is common in this, so this and this is the common, so these two is essential prime implicant, these two is essential prime implicant, and we have four different, like this and this 2 and 3 4, so we have four different like this term. So we have four prime implicant and two essential prime implicant, so we can calculate by this also. So this is called this is suppose y1, this is y2, so we can generalize like y1 intersection y2 will give essential prime implicant, essential prime implicant, and y1 intersection y2 will give prime implicant. Thank you for watching the video. Please like the video, share the video and subscribe the channel. Thank you.